I went through over the weekend, and our plan is to finish lesson, what are we in, 1.1 today. I went through over the weekend, and I was looking at the homework and looking at the types of problems. So there was one thing that I wanted to mention. So on Friday, I don't know how much you guys remember from Friday, but our last topic was x and y intercepts, right? With x and y intercepts, we talked about where they cross the x-axis, and then one of the values is always 0. When we did this, I just had you guys saying, okay, x-intercepts are 3 and -3. Y-intercept is -3. We just left them in terms of a single number, okay? Most of the time in the homework, when they asked you for intercepts, they just said, what are the intercepts? And you just listed a number, or you could do number, comma, number. However, I did catch at least one place in the homework, when you go into that tomorrow, that they had you give them as ordered pairs. So if you're looking at the intercept of 2, what is that as an ordered pair? In other words, if you think about a graph that crosses the x-axis at 2, as an ordered pair, that would be 2, 0. And x-intercept of -2 would be -2, 0. So just wanted to comment on that a little bit. A y-intercept then, of course, you're going left to right, 0 and up. So a y-intercept could be the ordered pair of 0, 4. So one of the things when you guys get into Savas tomorrow, you have to watch the directions. They will tell you each problem how they want you to write an answer. Okay? Whether, if they just ask for the x and y intercept, you can just list a number. If they specifically say as an ordered pair, then you're putting that 0, whichever 0 it was, into the ordered pair with the number. Okay? So just something to be aware of there. Okay, 2 topics left to go then. Now, if I briefly, what did we talk about before x and y intercepts? Domain and range. Okay, so domain and range is something you'll have to remember when you get into the homework. That's going to be the tough part, guys. I'm giving you a Friday, Monday lesson. I'm not letting you get started on the homework till Tuesday, mainly because, we have to get you guys logged in. But domain and range, remember domain are your x values, range are your y values, okay? We did x and y intercepts where you put your 0 in. And now we're ready to talk about positive and negative intervals on a graph. Okay. When we talk about positive intervals, we are talking about when the y value is positive. So notice, positive intervals happen when the y value is positive, or in other words, above the x-axis. So positive intervals where the y value is positive. So if my x-axis here breaks it up, we're looking for where the y values are positive. Negative intervals happen when the y value is negative, or in other words, below the x-axis. Okay, so when we're looking for positive and negative, you're just looking, that x-axis is your dividing line, and you're looking for above and below. Now, the first example we're going to look at, they ask us for what interval is each function positive and then negative. They're giving us the equation, y equals x squared minus 9. One of the things we'll talk about when I get you guys on the iPads is if they don't give you a picture of the graph, I'm going to tell you to use Desmos to do that because we don't know how to graph all these graphs right now. But y equals x squared minus 9. Another parabola here, so another U shape. Where is it positive? Where is it negative? So what's our dividing line? We're looking where? Either above or below the x-axis. So our x-axis here is going to be our dividing line. Anything above the x-axis is going to be considered positive. So where's my graph above the x-axis? We've got a portion over there that's above the x-axis. And is that the only portion above the x-axis? No. You got a portion over here that's above the x-axis. So those are going to represent, we're going to talk about how to explain or how to state those answers, but those are going to be my positive intervals. Where negative intervals going to be? My graph is going to be negative where? Below. So negative is going to be this entire U shape here. Identifying them is easy. It's how do we give our answer. I think I'm going to start with negative first, and then I'll put positive up above in a moment. I kind of feel like negative will be easier. We talk about negative intervals here. I think I'm just going to have you guys do interval notation. I never saw any place in the homework where they use the inequalities, less than, greater than. But we're going to get these answers in terms of x's. So when does my graph start being negative? At what x value does my graph start being negative? When does it cross into the negative world? Not at 5.
Here.
What number would this be here? This would be a negative 3. Okay, so based on the fact that that's labeled as 0, that's labeled as, I don't even know if you can see, I think the negative got cut off, but assume negative 5 because it's left. So at negative 3, it starts being negative. Now, follow the graph. It's negative, it's below the x-axis, it's below the x-axis, it's below, it's below. When does it stop being negative? At what x value?
3.
At 3, at positive 3. So here, this graph is negative from negative 3 to positive 3 because that's the interval that is below the x-axis. So we're going to write this in interval notation like we were on Friday. Starts being negative at negative 3, comma, it stops being negative at 3. Now, when we talk about specifically at the point negative 3 and 3, at those points right there, keep in mind the graph is not negative and the graph is not positive. So with that in mind, I'm going to use parentheses around either side. Okay? So my negative interval is represented from negative 3 to positive 3 because that is when it is below the x-axis. Now, let's look at positive. Positive is going to be when it is above the x-axis. So when does my graph start being positive? It stops, well, I guess we could say right here, it stops being positive when? When it gets to negative 3. When did it start being positive? Where does this graph start? Yeah, infinity. In terms of, it doesn't just start here, say at negative 4 or 5, does it? This graph keeps going up and up and up, and as it keeps going up and up and up, it's going farther left, left, left. So how far left does it go when it starts? We're going to call that negative infinity because it's going infinitely left. Okay, so the graph starts all the way left at negative infinity, comma, it's going to stop being positive at negative 3. Now, if you remember anything from Friday, what do we always use with infinities? Parentheses. And then the negative 3, it's not positive, it's not negative, it's 0. So since it's not positive, we're going to use a parenthesis. Now, we can just put a comma in between because do we have another place that this graph is positive? We have another section here, don't we? So we're positive from negative infinity and negative 3. Then from negative 3 to 3, we're negative. When do we start going positive again? At 3. 3 to where? How long are we positive? Yeah. As you're going infinitely up, you're going infinitely right, so 3 to infinity. Again, infinities always use parentheses, and guess what? The 3 also uses a parenthesis because it's neither positive nor negative. Okay, as I said, I don't think we need to talk inequalities here. It's just the interval notation. Questions? Not sure what questions to ask, maybe? See how the next one goes? I don't know. Claire?
Would we ever use brackets instead of parentheses, and if so, like when?
In interval notation, you would not. Okay? If you remember in domain and range, we did some. Or I don't know if we ever did in domain, but in range, domain and range you could. We would definitely use some brackets there. But in interval notation, or positive, negative intervals, I don't think you'd ever use brackets because when it's changing from positive to negative or negative to positive, it's neither at that point. It's 0, so we don't include it. Okay. Okay, let's try this other one. Y equals 2x plus 10. You have a graph there to look at. As like all of my others, you can assume that this is a infinite graph. Positive and negative. So where is my, we've got to look for above and below the x-axis. Where's my x-axis? Right here, yes. So there's the x-axis. What do you want to start with, positive or negative?
Negative.
Negative? Okay. What are we thinking? Where is my graph negative? Any place, I mean, just in words, any place it is what? Below the x-axis? So I think we can agree it is below the x-axis over here. Thoughts on that interval? When did it start being negative? It's going down, 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 down. -5. We'll talk about -5, but I'm not going to say it started being negative then. I guess. I see what you're saying. Okay, we can't agree this point is -5 here, yes? My 5 kind of got covered up there. But in terms of if I start at the left, where am I starting from? I'm really starting, when I start at the left, I'm starting from way down here. Yeah, so I'm starting all the way at the left. So I'm starting negative infinity up to when do we stop being negative? And we're going to stop being negative at -5. So what I'm looking for there is negative infinity to -5. And again, that negative infinity represents how far left does this graph go? How, it goes negative infinity. Negative infinities are always parentheses. And at -5, that point is neither positive or negative, so we're going to use a parenthesis. Now, as we trace this, what happens? It was negative. What happens as we hit the x-axis? Now it's going to be positive. So now from this point up, it's positive. When did my graph go positive? When did it start being positive? When it crossed through what? -5. When's it going to stop being positive? Never, so infinity. Infinity is always use parentheses. The -5 is neither positive nor negative. Technically, at -5, what is the y value? It's not positive, it's not negative, it is 0. And that's why, it's the breaking point. Okay. With that in mind, questions on that section? Okay. Okay. One more section then. And that is talking about where a function increases or decreases. Excuse me. So positive or negative is basically above or below the y-axis. Increasing is decreasing. Is it going up or is it going down? Okay. Officially, a function is increasing if the y value is increasing. And you'll notice it does say as the x value increases. That's just saying as you move to the right on the graph. If your y value is increasing, your graph is increasing. Okay, so increasing, your y value is increasing. Function is decreasing. Well, again, we're always reading left to right. So function is decreasing if the y value is decreasing as x increases. So as you move right, that y value needs to be decreasing. Now, my notes only have increasing and decreasing in there. Let me throw one other word in. Identify where a function increases or decreases Or the other word I'm going to throw in at you is constant. We don't do a whole lot with it, but Savas does throw this word in at you, so I've got to make sure that you have an idea of what we mean. Increasing is going up. Decreasing is going down. What's constant? Something's constant, it's just horizontal, right? It's not going up or down. So just kind of be aware of that. Okay? Well, I'll talk about that a little bit. So, when we give these answers, notice it says for what values of x is each function increasing or decreasing. So as we give our answers, we're going to be as we read from left to right. Excuse me. As I start looking at this graph, I'm always going to start at the left. What am I doing as I start at the left? What am I doing first? I'm going up, yes, which means I am increasing. So we're going to start by talking about increasing. Now, where did I start increasing? Where did my graph officially start? It's coming from down, right? It's also coming from the left. Okay, so my graph started increasing at the far left side, like past Mr. Arnold's room, down to Mrs. Holman's room, wherever we want to talk about there. So where is that? Negative infinity. So it started increasing at negative infinity. Where's it going to stop increasing? What do you think?
2 or 0.
One of them, right? Okay, so let's figure out which one it is. It's going to stop increasing at this point. What is the ordered pair at that point? The ordered pair is 0, 2, yes? Okay. We're giving our answers in terms of what? X. What's the X value there?
0.
0. So we're going to say that it stops increasing at 0. It's really easy to say 2 there, isn't it? Because you guys see the 2. But the 2 is how high does it go? It goes as high as 2. But when does it stop? It stops at 0. Now, infinities, what am I going to tell you to put with infinity? Parenthesis. The 0. With the 0, it stops increasing there, right? But that also means it's going to start going the other way. So we also use a parenthesis because at 0 it's neither increasing or decreasing. I'm going to throw a word in for you. You guys familiar with the word max or maximum? It's a max at 0, 2 because that is our high point, right? So I just, again, throwing in a word that homework throws in. Okay, after we reach that max, that high point, what happens? What am I doing now? We're decreasing, aren't we? As we move right, our graph is moving down. So we are decreasing. When do we start decreasing? Like?
0.
At 0. And the question is, when did we stop increasing? We stopped increasing at 0. So when are we going to start decreasing? At 0. Those points should match. So we're going to start decreasing at 0. When are we going to stop decreasing? Infinity. We're going to keep going. We're going to keep decreasing. And we're going to keep going infinitely right as we do that, right? So now, 0 to infinity. It's as you move left to right. Infinity, of course, uses a parenthesis. 0 also uses a parenthesis. It's neither a increasing or decreasing at 0. It's that changing point. Okay. Where was this graph constant? Was it ever constant? No. Okay. You're going to see some in homework where they give you where is this graph increasing? Fill in the answer. Where is this graph decreasing? Fill in the answer. And then they'll say, where is this graph constant? Well, you have I don't know if I want to say multiple choice, but an option to pick that says never constant. You would pick this graph was never constant. Fair enough? Okay. Okay, ready to try the next one? G of x. We're going to start at the left. What's my graph first doing when you start at the left? As I move from left to right, I am tracing downwards, yes? So the first thing my graph does is it decreases. Where does it start decreasing? How far left were we?
Negative infinity.
We were all the way left. So we were at negative infinity when we started decreasing. When are we going to stop decreasing?
Two.
2? Yes? No? What is that ordered pair there, guys? That's what I'm going to have you think. That ordered pair is 2, -4, it looks like. But we're giving our answers in terms of the x values. So it's going to stop decreasing at 2. Infinities always use parentheses, and the 2, it's our changing point. So it uses a parenthesis. It's neither increasing nor decreasing at that specific point. Okay. What happens after we cross through that point? Now as I trace this graph, I am moving up. We're increasing. Okay. When do we start increasing?
2.
At 2. Because where did we stop decreasing? At 2. So we're going to start increasing at 2. When are we going to stop increasing? Never. We're going, as we continue to go up, we're going infinitely right, so infinity. And guess what? We're going to use parentheses. What do you think that point at 2, -4 is called? It's a what?
Minimum.
It's a minimum. Now, it's a minimum, and this is what I want to point out because there's something about this in homework. It's a minimum because what did my graph do? My graph changed from decreasing to increasing, so thus it's a minimum. What happens at a maximum? Your graph changes from increasing to decreasing. Okay? I would say it's pretty logical, but when you're reading in the homework, I want to make sure it makes sense. Okay, one more increasing, decreasing.
Just for clarification.
Yes.
On this first graph, you're stating we read them from the left to the right.
Mhm.
Okay, that's why we know it increases first and then decreases last.
Yep, we're always reading because we're giving our answers in terms of x values. So we're always reading left to right. Yep. And I will say, what's the thing you guys are going to miss on quizzes and tests the most this unit? That's going to be one of the things. Because it's so tempting to put them in terms of y values and things like that. So. Okay. What about our third graph here? What's it doing? What's it start off doing? Let me ask that way.
Decreasing.
Decreasing? Can we agree? Because we're going to start where? We're going to start at the left. And the first thing I'm going to do is I'm going to start from the top, and it's decreasing. How long is it decreasing? Does it ever stop decreasing? No. Okay. So, when did we start decreasing?
Negative infinity.
Negative infinity, because we're all the way to the left, yes? I don't care that we came from up above. I can't, x values, we came from the left. So that is negative infinity. When do we stop decreasing? never, which is pos infinity, right? Now you're head up towards Spanish, the office. You know, we keep going infinitely right as we continue down, so that is pos infinity. And hopefully I've stuck something in your heads. Infinities use parentheses. When is this graph increasing? Never. When is it constant? Never. Okay. One other thing before I turn the page. There's one question that was randomly thrown in on, and I'll use this as an example, where on this question, for instance, they might ask what g of 2 is. We talked on Friday. Remember, g of x is just another fancy name for y, okay? But if they ask what g of 2 is, they're asking what is this equation equal to when x equals 2? Any thoughts what g of 2 is? It's right there in front of you. And what's the y value at 2? -4. So the idea here that g of 2 is -4, for example, because on this graph, when x is 2, the y value is -4. Okay? You've done that somewhere along the line when you've learned functions back in Algebra 1, guaranteed. I just know we don't necessarily remember it. Okay, I think that's all I have on that page. Questions on this page? Okay, the back page is just a chart, and it's more of a reference chart here, okay? It has some interesting information on it in terms of it gives you 4 columns, and it breaks you up into, okay, a linear graph, which is of the form y equals x. I think y equals mx plus b is what you guys probably think of the most. So linear, diagonal line there. A quadratic. We'll do a lot with quadratics this year. Y equals x squared, so that's that U-shaped graph. Absolute value. We're going to do a little bit with those in this unit 1 here, but that is the V-shaped graph. And a constant. Okay, that's just y equals a number. There's an example of a constant graph. So generally what they've talked about here, the domain and range on each of these. The fact that the domain on all of them is negative infinity or positive infinity because they both all go infinitely left and right. The range on the line goes infinitely low and high. On these middle two, they start somewhere and go up. And so that's where you see the range there. And then on this one, it's a little bit different because the only y value it ever touches is 1. They've got, generally speaking, what increasing and decreasing will look like, which you go back and look, matches up with our other page. And generally speaking, what your intercepts are. Now, this is if the graphs aren't moved or shifted any. But generally speaking, what kind of intercepts you have. Okay? So that's a chart that can be helpful to refer to when you're looking at homework. Which, one thing I hope, when you go to look at homework, are you the type of people that you have your notes beside you, I hope? Because that's what I want you using. Okay? When you get stuck on homework, grab those notes out. Okay? Questions? Not until you start the homework, right?